It is, of course, the king of the planets, and the fifth from the Sun. Stay with me in this video to learn everything that there is to know about Jupiter. First, let's look at the physical characteristics of Jupiter. The first thing you notice when looking at Jupiter is the thick cloud bands that run horizontally across its surface. This is caused from the planet's fast rotation that separates gases into long jet streams, sometimes at speeds of 540 km per hour. The vivid colours seen in these bands could be the result of sulfur and phosphorus-rich plumes of gas rising up from the warmer interior. Jupiter got its name from the king of the gods because of its enormous size. It is twice as massive as all of the other planets combined and has the strongest surface gravity of all the planets at 24.8 meters per second squared. Its mass is 1.898 times 10 to the 27 kilograms, or 318 times the mass of the Earth. It is 139,800 kilometers across, almost 11 times wider than the Earth. Its density is 1.33 grams per centimeter cubed, which is mainly due to the hydrogen and helium-based interior of Jupiter. The uppermost clouds that are visible on the surface have 3 layers. The topmost clouds are made of ammonia, while the next are comprised of ammonia and sulfur, and the lowest is clouds of water vapor. These layers are about 71 kilometers in depth, with the topmost temperatures reaching lows of minus 145 degrees Celsius. Below that is mostly clouds of hydrogen and helium, similar to the composition of the Sun, and some liquid hydrogen that has been compressed by the sheer weight of the planet. But the very center of Jupiter is where it gets really weird. The pressure is so great that the electrons are stripped off the hydrogen atoms, creating liquid metallic hydrogen, a form of hydrogen that has conductive properties. This material is what gives Jupiter an enormous magnetic field that we will talk about soon. This metallic hydrogen outer core comprises 78% of the radius of the planet, until finally we reach the iron core at a temperature of 24,000 degrees Celsius. Situated 22 degrees below the equator is Jupiter's iconic Great Red Spot. The spot is actually a storm twice as wide as Earth that has been raging for over 300 years, the longest lasting storm in the solar system. Because there is no solid surface on the planet, there is nothing to slow down the gases swelling across its exterior. However, in the past 20 years, the Great Red Spot has been shrinking. The red spot used to be longer and flatter, but now it has changed to a more circular shape. It is not known why the red spot is shrinking. Jupiter has an enormous magnetic field that stretches from 1 to 3 million kilometers away from the planet. It is about 18 to 54 times more powerful than Earth's, and is able to trap charged particles and accelerate them to high energies, bombarding its moons with high levels of radiation. These charged particles create some of the most beautiful and impressive auroras in the solar system. This picture from the Hubble Space Telescope shows the blue aurora over the Jupiter's North Pole. Let's take a look at Jupiter's orbit and rotation. Jupiter has the fastest rotation in the solar system, completing one rotation every 9.9 hours. This is quite an impressive feat, considering it is the largest planet in the solar system, and also causes the equator to rotate at over 12 kilometers per second. The Jupiter year, however, is just under 12 Earth years, which means that there are over 10,000 Jupiter days for every Jupiter year. Jupiter has an average orbital radius of 779 million kilometers, 5 times further out than Earth. At perihelion, or its closest distance to the Sun, the planet is 741 million kilometers away, while at aphelion, or its furthest distance from the Sun, the planet is 817 million kilometers away. Because Jupiter's axial tilt is only 3.1 degrees, it does not have any seasons. Let's explore the many moons of Jupiter. Overall, Jupiter has 53 named moons, and another 26 awaiting confirmation, bringing the total number of moons to as many as 79. There are 4 main moons discovered by Galileo in 1610, Io, Europa, Ganymede and Callisto. These are known as the Galilean moons, and are so big that they can be observed through a small telescope. Io is the closest Galilean moon to Jupiter, and also the most volcanically active object in the solar system. It orbits 350,000 kilometers above the topmost clouds of Jupiter, and completes its orbit every 42 hours. The surface of Io has a splotchy yellow and brown appearance, with pools of lava lakes and floodplains of liquid rock. This volcanic activity is a result of the surface being squeezed and pulled by Jupiter's immense gravity. Some parts of the surface bulge up and down by as much as 100 meters, and its elliptical orbit only increases this process. Plumes of sulfur dioxide and lava can be shot as high as 400 kilometers above the surface due to the weak gravity of the moon. It is about the same size as Earth's moon and has a surface gravity of 1.7 meters per second squared. Europa is the next Galilean moon and orbits Jupiter every 85 hours. It is the smallest of the Galilean moons at 3,121 kilometers wide and orbits 671,000 kilometers from Jupiter. The surface of Europa is all ice, making it one of the most reflective objects in the solar system. However, what lies below the icy crust is even more interesting. There is a good chance that it has a subsurface ocean that is twice the volume of water than on Earth. Given the chance that the ocean is near the center of the planet, it could be warm enough for life to survive. On the surface, the planet looks to have an array of cracks spreading across its exterior, possibly caused by the tidal forces of the subsurface ocean. As well as this, possible plumes of water have been spotted by the Hubble Space Telescope, but these remain to be confirmed. Europa is definitely one of the best places in the solar system to look for life. Ganymede is the largest moon in the solar system, stretching 5,268 kilometers across, even bigger than Mercury. It orbits 1.07 million kilometers away from Jupiter, and completes its orbit every 172 hours. It is the only moon in the solar system to have a magnetic field, which causes auroras in the north and south poles. Its surface is made up of two types of terrains. The first is bright ridges and grooves that carve their way through the darker and older parts of the moon. The topmost layer of the planet is ice, and there is substantial evidence for an underground ocean on Ganymede. Though it is the largest moon in the solar system, its gravity is only 1.4 meters per second squared. Callisto is the furthest Galilean moon from Jupiter, orbiting 1.88 million kilometers away. It is also one of the most heavily cratered objects in the solar system, and takes 17 Earth days to orbit around Jupiter. Callisto has some of the oldest rocks in the solar system, and has been bombarded with asteroids for over 4 billion years. However, most of these craters are still visible, suggesting that Callisto has little to no tectonic activity. The surface is icy, similar to the other moons, and it may also harbour a saltwater ocean beneath the crust. Callisto is the third largest moon in the solar system, with a diameter of 4,820 kilometers. Finally, let's look at some interesting features of Jupiter. Perhaps the most beautiful planet in the solar system is Jupiter, as revealed by the Juno satellite, which has been orbiting the planet since 2016. As you can see by the photos that Juno has revealed, the planet looks completely different up close. The clouds in the upper atmosphere all merge and mix, producing extremely intricate patterns. Another interesting feature of Jupiter is that it has a faint ring system. The ring system around Jupiter is harder to see because it is comprised of fine dust rather than ice like around Saturn. In this picture, Jupiter is eclipsing the Sun, as seen from Galileo. A thin ring system around Jupiter is easily visible here, when seen by the reflected sunlight. These rings were created when meteoroids struck into the small asteroid-like moons of Jupiter. The dust is then vaporized and exploded into Jovian orbit to form the rings. Finally, I will leave you with perhaps the most spectacular, or at least my favourite, image taken by the Juno spacecraft. Here it clearly shows the North Pole of the planet in all of its glory, but what I noticed most is the deep blue colour. This image is what I think highlights the true beauty of the solar system. And if you stay with me this far, remember to leave a like and subscribe to not miss the next planet in the solar system, Saturn. Until next time, goodbye.